All right, last lesson for Unit 6. We're going to solve some radical equations and inequalities. Let's dive right in. We're going to kind of hit the ground running with some examples and see what happens. We've got a handful of examples, and then we're going to be done. This is liable to be a little bit shorter than a lot of our lessons. We'll see how it goes. So let's solve these two. So if you only have one radical, which we do in this problem, not in this one, right? We got 1, 2 over there. We need to, the first thing we want to do, if we only have one, is we need to isolate that radical. So we need to solve for the radical. So we need to get rid of this 4. How do we get rid of that 4? Well, we do that, of course, by subtracting 4 from both sides. That cancels, leaving us with the square root of x plus 4 over here equal to 3 over there. Now we need to get rid of the square root. Well, how do we get rid of the square root? What's the opposite of square rooting? What's the inverse? Well, it is squaring, right? We've kind of done this a lot, or done something like it. That's squared. So we end up with x plus 4 equals 3 squared is 9. How do we get rid of this 4? We subtract 4 on both sides. End up subtracting 2 different 4s off of this problem. We end up with x equals 5. Right? Easy peasy, lemon squeeze. Easy. Something's not right because that's, yeah, well, this is not the problem that I meant to write down, but we'll see. Now, so what I was about to say is still true, even though this isn't the problem I meant to write. Before we can be sure that this works, we have to, it's always a good idea to check your solution when doing an equation, but you really have to do it with square roots because there are a lot of cases, many cases where it doesn't really have a solution. So we need to check this. And the way we check it is the way we always check equations. We just substitute back in for the variable. So we're going to put a 5 right here, plus 4 on the outside equals 7, and see if it works. So the square root of 9 plus 4, does that equal 7? 3 plus 4 does equal 7. So this one checks. That's great. Kind of giving a lot of hints what's coming in the future. So this guy, we don't have a single square root. So we got to do something else. We got to use some other strategies. What we're going to do is we're going to go ahead and try squaring the both sides, right? So we can get rid of this big square root over here and then kind of deal with this one as it goes. So let's see what happens. So let's square both sides to get rid of that big square root, right? So we end up with x minus 12 on this left side. On this side, now, an easy mistake to make would be like, okay, the answer to this side is 2 squared minus x. But it's not. It's not that. You don't just distribute that 2. That's not correct. That's not how that works, right? Because this would be this times itself. So we are going to distribute. But we're going to do a big distributive property, right? So we're going to do foiling, right? So we're going to do 2 minus the square root of x times 2 minus the square root of x, right? And then we got to distribute that thing. So we're going to do 2 times 2, 2 times the negative square root of x, negative square root of x times 2, and negative square root of x times negative square root of x. We got to do all that mess, right? So let's do x minus 12. I'm just bringing this left side down, equals 2 times 2 is 4. And then 2 times negative square root of x is negative 2 times the square root of x. Excuse me. And then we've got negative square root of x times 2. So that would be another minus 2 times the square root of x. And then negative square root of x times negative square root of x would be positive just x, right? Because we've got the square root of x squared, and that cancels out because that would be square root of x on square root of x with square root of x squared, right? All of those layers in there. So what can we do now? Well, we can do a little bit of cleanup. Let's go ahead and do that. We can combine some like terms over here, right? This one and that one. So I'm just going to bring down x minus 12 equals 4 minus 4 times the square root of x, because negative 2 plus negative 2 is negative 4. That's where that comes from, plus x. So what do we need to do now? Well, we're to kind of to where we were over here, sort of. We've got a single radical, so we can isolate it and then square both sides. So that's what we're going to do. Okay, so let's move the 4 over. Minus 4, minus 4. We'll move the x over, so minus x, minus x. Okay, so that's kind of handy because the x's cancel here, and then negative 12 plus negative 4 is easy peasy. That's negative 16. So this was also canceling, right? So equals negative 4 times the square, oh my gosh, having a hard time, square root of x, right? So how can we get rid of that negative 4? It's multiplied, so we're going to divide it. So divide by negative 4 and divide by negative 4. That cancels, leaving us with the square root of x. I'm just going to flip it over here because we're used to having the variable on the left side. Makes us all feel nice, warm, and cozy. Negative 16 divided by negative 4 is positive 4. Get rid of the square root by squaring both sides. Squaring. I'm having a hard time with those little 2's today. So we end up with x equals 4 squared, which is 16. Okay, so we've got to go back and run our check. Circle this answer over here. Run our check. So we're going to do the square root of 16 minus 12 equals 2 minus the square root of 16. 16 minus 12 is 4, so this is the square root of 4 equals 2 minus the square root of 16 is 4, so 2 minus 4. So you can probably already see that this isn't going to work, but in case you don't see that, square root of 4 is 2, but 2 minus 4 is negative 2, and that's why sometimes these don't work, because of the way negatives work with radicals. So this, in fact, has no real solution, right? No real solution. Okay, let's do another one. All right. So we've got a radical here, right? It's in exponential form, but we've got a radical, and we've only got one of them, so we're going to start by isolating it, right? So we can add 4 to both sides. Plus 4 and then plus 4. That cancels, leaving us with 2 times the cube root, or 6x minus 3 to the 1/3, which is also a cube root, equals 4. All right, how do we get rid of the 2 in front of there? Well, it's multiplied, so we're going to divide 2 on both sides. That cancels, leaving us with 6x minus 3 to the 1/3 equal to 2. How do we get rid of to the 1/3? Well, we got to raise it to the third, right? Because 3 times 1/3 is 1, so that'll make it disappear. So we're going to cube both sides. So that cancels on this side, leaving us with just 6x minus 3, and then 2 cubed is 8. Going to get rid of that minus 3 by adding 3 to both sides. Cancels over here, leaving us with 6x equals 11. Divide the 6 off. And we end up with x equals 11/6. All right, we better check that to make sure it works. So we're going to substitute it in here. Substitute it. So 2 times 6 times 11/6 minus 3 to the 1/3 minus 4. Does that equal 0? So we got to do the parentheses. So we got to clean up the inside. 6 times 11/6 is 11, right? So 2 times 11 minus 3 to the 1/3 minus 4. Does that equal 0? 11 minus 3 is 9. No, just kidding. It's a good thing it's not 9. Then this wouldn't work. 8 to the 1/3 minus 4 equals 0. 8 to the 1/3 is the same as the cube root of 8, which is 2. So 2 times 2 minus 4 is going to equal 0. It's going to check. It works. Yay. Great. Let's do another one. We got 2 more. This one an inequality, and then we are through with this lesson already. All right. So we're going to isolate the radical, right? We've been doing with same. We're going to add 6 to both sides. Plus 6, plus 6. So we end up with 3 times the 4th root of 2n plus 6 equals 6. We've got to get rid of that 3. It's multiplied, so to get rid of it, we divide by 3. Divide by 3. Cancels over here, leaving us with the 4th root of 2n plus 6 equals 2, because 6 divided by 3 is 2. How do we get rid of the 4th root? Well, we raise it to the 4th. Easy peasy. Raise it to the 4th. Excuse me. So we end up with 2n plus 6 on the left side. 2 to the 4th is 16. Right? So how do we get rid of the 6? It's added, so we subtract 6 from both sides. Cancels here, leaving us with 2n equals 10. The 2 is multiplied. We divide to get rid of it. 2 divided by 2. So n equals 5. We better double check it to make sure it works. So 3 times the 4th root of 2 times 5 plus 6 minus 6 equals 0. 2 times 5 is, of course, 10. Plus 6 is 16. So 3 times the 4th root of 16 minus 6 equals 0. The 4th root of 16 is 2, because 2 to the 4th is 16. 3 times 2 is 6. 6 minus 6 is 0. This is going to work. We did it. Let's do one more. We're going to solve and graph the solution on this inequality right here. Okay? So, just like with any other inequality, we do it basically like there's an equals. However, there's an issue here, and because there's like another half of this, but it's not like an absolute value where we split it into positive and negative. That's not really what we're going to do. What we're going to do is we know that the inside of this radical cannot be negative. So we're going to set up an inequality for that, and then we're going to kind of set up an inequality for the entire thing. So let's start with the little inside one there. So for the inside one, we know that 5x minus 10 has got to be greater than or equal to 0, right? Because we can't have a negative in here. So we're going to make this little inequality and solve him first. So we're going to add 10 here, add 10 here. So we end up with 5x is greater than or equal to 10. We divide by 5. Divide by 5. So x is greater than or equal to 2, right? Easy peasy lemon squeezy. So that's a piece of the puzzle. Now let's solve this whole thing for x. So we're going to divide both sides by 3 over here. Divide both sides by 3. This by 3, this by 3 to get rid of that, to isolate the radical. Okay, so that would have been what we were going to do, but that's not what I was supposed to write down, and I'd just as soon not do that way. So this problem should have had, I copied it wrong. That's what happens when you are in a hurry to get things done for folks and you end up making making mistakes. This should have been 3 plus. That's gonna work out with a little bit less ugliness. So just kidding, we're not going to divide by 3. Instead, we're going to subtract 3 from both sides, right? Because it's added. And so now that radical is isolated. So we've got the square root of 5x minus 10 is less than or equal to 5. Now, you might be thinking, do I switch this thing? That's only for multiplication and division of a negative, right? We're just subtracting something so it doesn't flip, right? How do we get rid of this square root? Well, we square both sides. We've been doing that this whole lesson. Easy peasy. We're going to square this, square that. It's going to cancel on this side, leaving us with just 5x minus 10 is less than or equal to 5 squared, which is 25. You get rid of this 10 by adding 10 to both sides, plus 10 and plus 10. So then we have 5x is less than or equal to 35. And then we're going to divide 5 on both sides. Divide by 5, divide by 5. So x is less than or equal to 7. All right, so we're going to graph it, but we need to double check each one of these intervals to see whether they work. Now, this checking with an inequality is a little bit different than checking with an equation, right? Because we're not checking specific numbers necessarily. We are checking intervals, right? We've done this before in this class, so hopefully you kind of remember what's going on. So we want to check this interval right there, this interval right there, this interval right there. And what we think should work based on what we have is x is going to be less than 7 and greater than 2. So we think that this is going to work, but this isn't and this isn't. Right? So that's what we think is going to happen. Let's double check and see what happens. So we need to pick a number over here, right? So I've said many times, and I still agree with myself, that if you have the possibility to pick 0, because that's a nice, easy number. So we're going to do 3 plus, let me totally change colors here. 3 plus the square root of 5 times 0 is 0, so we've got negative 10. Is that less than or equal to 8? So that doesn't work. I was about to say, that doesn't work, but then I realized, oh, that doesn't work. which is what we expected, right? Because this is not going to work, because that's going to give us an imaginary number of some sort, right? So this segment definitely does not work. Great. So far, so expected. All right. What about this section? So let's pick 5. Why not? 5 seems like a simple number that's in between 2 and 7. So 3 plus the square root of 5x. So 5 times 5, which is 25, minus 10 is less than or equal to 8. So 25 minus 10 would be 15. 3 plus the square root of 15. Let's pull up our calculator real quick. Okay, so we're going to do the square root of 15. And we may as well do plus 3 while we're at it, because that's easy peasy. Plus 3 equals, how about approximately equals 6 point something is 6 point something less than or equal to 8. Yes, it is. It does work. So it looks like we are going to shade in here. We're feeling good about that, but we need to double check this last section. So let's pick a number over here. How about 10? So 3 plus the square root of 10 times 5 is 50. Minus 10. Is that less than or equal to 8? All right, so 50 minus 10 is 40, so 3 plus the square root of 40. Is that less than or equal to 8? Probably not. The square root of 40 out of the thing plus 3 is approximately equal to 9.3. So 9 point something. Is that less than or equal to 8? No, it is not. So this doesn't work. So we are going to shade exactly where we thought we were going to shade. Easy peasy, lemon squeezy. Now, I feel like I've said this before in videos, but I will note once again, perhaps or possibly the first time, hopefully not the first time, that yes, and the way this works is if it doesn't work for any number in this range, or a number in this range, it doesn't work for any number in this range. If it works for a number in the range, then it works for the entire range, all the way through. And that, believe it or not, is that we're not at 30 minutes this time, only 20 minutes. We can do this. We're almost there, which means we're almost to the test. So, study. I'll see you in class. Do your homework, all those things. If you're not one of my students, thanks for joining us. Hopefully this was helpful to you. We'll see you guys later. Bye-bye.